Question 10 reads, if k is a positive integer, let k box be defined as a set of all multiples of k. All the numbers in which of the following sets are also in all three of the sets 2 box, 3 box, and 5 box. So this is a strange functions question because it defines this unusual operator k box, which is the set of all multiples of k. And it's also a factors question because when it comes down to answering the question, you really just need to think about factors. The hardest part about this question is translating what they're asking you into, figuring out what you need to do here. So they're asking you all of the numbers in which of the following sets are also in all three of these sets. What are these sets? Let's translate and say all of the multiples of which of the following numbers are also multiples of 2, 3, and 5. That's really what you're being asked here. So which of the following numbers has all of their multiples also a multiple of 2, 3, and 5? Well, let's get started. All multiples of 5 aren't necessarily multiples of 2 or 3. For example, 10 is not a multiple of 3, so that's out. Multiples of 6 are not necessarily multiples of 5. For example, 12, definitely not a multiple of 5. Multiples of 10, while definitely multiples of 5 and 2, just its prime factorization, right, are not necessarily multiples of 3. For example, 20 is a multiple of 10, but not a multiple of 3. Multiples of 21 will not work. 21 itself is not divisible by 5. What we get to finally is 60. Multiples of 60 will always be a multiple of 2, a multiple of 3, and a multiple of 5. That's because 60's prime factorization contains the prime numbers 2, 3, and 5. So that means that any multiple of 60 will also be a multiple of these three numbers. The correct answer is E, 60 box.